Hello dear students. In last session we have discussed about superposition theorem and we solved some problems having independent sources. And this session is about solving some problems with dependent sources. Let's start with the problem itself. This is the question. Find the current through 6 ohm resistor in the figure using superposition theorem. Here we are having two independent sources, a 15 volt source which is an independent voltage source, a 10 volt source which is an independent voltage source, and here we have a 3 into I which is a dependent current source. Current in this source is 3 into I, where I is a circuit parameter. I is the current flowing through the 6 ohm resistor. So current from this dependent source depends upon a parameter in this circuit, hence it is known as dependent source. Okay, now the first step is to consider the 15 volt source acting alone. So the circuit will come like this, and here I dash is the current flowing through 6 ohm resistor. So this will be changed from 3I to 3I dash, because in this circuit current through 6 ohm resistor is I dash. So this will be 3 into I dash. Now our aim is to find out I dash. In order to find out I dash, we are using supermesh analysis. For that, two mesh currents I1 and I2 are marked. Now from this diagram itself, we can write that this I dash and this I1 are equal. This is the first equation. I dash is equal to I1. Again, from this diagram, while considering I1, I2 and 3 into I dash. I1 flows downwards, I2 flows upwards, and the resultant is 3I dash which flows upwards. So from this diagram, we can write I2 minus I1 is equal to 3I dash. I2 minus I1 is equal to 3I dash. I dash is I1 from this equation. And rearranging the equation, we will get 4I1 minus I2 is equal to 0. It is equation number 2. Now, we have to write the loop equation. We cannot write a loop equation for this loop because voltage drop across this element is not known. We cannot write voltage drop across this element. So, the only loop where we can apply KVL possible is this loop. So we are considering this loop and applying KVL to this loop. While applying KVL to this loop, the equation will be 15 minus 6 into I1 minus 8 into I2 is equal to 0. Rearranging the I1, I2 terms, so we will get the equation 6I1 plus 8I2 is equal to 50. Now upon solving these 2 and 3, by solving equation number 2 and 3, we will get the values for I1 and I2. So we got I1 as 0.39 amperes and I2 as 1.57 amperes. And we know that I dash, or aim is to find I dash. I dash is equal to I1. So we can write I dash is equal to I1, that is equal to 0.39 amperes, which flows from left to right. So we can mark the direction from left to right. Then we are going to the second step. Second step is to consider the 10 volt source alone. So the diagram will come like this. Now current through the 6 ohm resistor is marked as I double dash. So this current will change to 3 into I double dash. Now our aim is to find I double dash. For that we are considering two loop currents I1 and I2. And from this diagram itself we can write I double dash will be equal to I1. Both are same. So I double dash is equal to I1. Now, from looking into the diagram itself, we can write the second equation. The second equation will be I2 minus I1 is equal to 3 into I double dash. I2 minus I1 is equal to 3 into I double dash, which is equal to 3 into I1, because I double dash is equal to I. Now, rearranging the terms of I1 and I2, we will get the equation for I1 minus I2 is equal to 0. Next step is to apply KVL to this law. Apply Kirchhoff's voltage law to this law. While applying Kirchhoff's voltage law to this law, equation will be like this: minus 6 into I double dash minus 8 into I2 plus 10 equal to 0. Minus 6I1 minus 8I2 plus 10 is equal to 0. Rearranging the terms of I1 and I2, we will get the equation like this. Now, upon solving equation 5 and 6, we will get the values for I1 and I2. Upon solving equation number 5 and 6, we got I1 is equal to 0.26 ampere and I2 is equal to 1.05 ampere. And I double dash is equal to I1, which is equal to 0.26 amperes, which flows from left to right. This is the direction of I2 double dash. Now apply superposition theorem. According to superposition theorem, I is equal to I dash plus I double dash. The statement of superposition theorem is that response in any branch in a circuit is equal to sum of the responses due to each and every individual sources when they are acting alone. So I is equal to I dash plus I double dash. I dash we got as 0.39 and I double dash is 0.26. So the net current through 6 ohm resistor is 0.65 ampere in this direction from left to right. Now we are moving to the next problem. This is the question, find the current Ix. Here we are having two independent sources, a 12 volt source and a 30 ampere current source, and a dependent voltage source is here. Now we are considering only the 30 ampere source. When 30 ampere source is acting alone, replace this source by a short circuit. So the diagram will be like this. Here we have to find Ix dash. This is Ix dash. So this source voltage will be 4 into Ix dash. Now in order to find out Ix dash, considering mesh currents I1 and I2. Now looking into the diagram, we can write Ix dash and I1 are same. And again from this diagram, we can write I1 flows downwards, I2 flows upwards, net current is 30 ampere downwards. So we can write I1 minus I2 is equal to 30. This is equation number 2. Next step is to apply Kirchhoff's voltage law to this law. We cannot apply KVL to this loop because here we are having a current source. We cannot apply KVL to this loop also because here we are having a current source. So apply KVL to this loop. Supermesh. So KVL equation will be minus 5 into I1 minus I2 minus 4 into Ix dash is equal to 0. Minus 5I1 minus I2 minus 4Ix dash is equal to 0. Rearranging the terms of I1 and I2, we will get the equation like this. This is equation number 3. Now, upon solving equation 2 and 3, we will get the values for I1 and I2. We got I1 is equal to 3 ampere and I2 is equal to minus 27 amperes. And we know that Ix dash is equal to I1. So we can write Ix dash is equal to I1 is equal to 3 ampere from left to right. Now, the second step. Second step is to consider 20 volt source alone. So, in order to draw the diagram, we have to replace the current source by an open circuit. Then the circuit will be like this. Now current through this branch is marked as Ix double dash. Our aim is to find out Ix double dash. Now from this loop we can write the Kirchhoff's voltage law equation. Applying KVL to this loop we can write 20 minus 5 Ix double dash minus 1 Ix double dash minus 4 Ix double dash is equal to 0. So we will get the value for Ix double dash is equal to 2 ampere from left to right. Now by superposition theorem, Ix is equal to Ix dash plus Ix double dash. 3 plus 2 is equal to 5 ampere from left to right. Now we are moving to the next problem. This is the question. Here we are having two independent sources, a 5 volt source and a 2 ampere source, and one dependent source 4 into Vx. Vx is this voltage. Vx is the voltage at this terminal. Now, the first step we are considering only 5 volt source. When 5 volt source is acting alone, redraw the circuit. In order to redraw the circuit, replace this current source by an open circuit. So the circuit will be like this. And this current is marked as I1 dash. Now apply KVL to this loop. We can write, before that we have to write the equation for Vx. In order to write the equation for Vx, we can write 5 minus 10 into I dash is equal to Vx. Vx is this potential. Vx is potential between these 2 points, these 2 terminals. Potential between, that means potential between these 2 terminals. Potential across these 2 terminals are 5 volt plus potential across the 10 ohm resistor is minus 10 into I1 dash. So we got Vx is equal to 5 minus 10 I1 dash, which is equation number 1. Then apply KVL to this mesh. Then applying KVL to this mesh, we will get the equation 5 minus 10 I1 minus 4 Vx minus 2 I1 dash is equal to 0. Rearranging the terms, we will get the equation like this, and we will get the value for I1 dash is equal to 0.54 amperes. This is the KVL equation. Here 5 minus 10 I1 dash minus 4 into Vx. We have substituted the value for Vx from this equation. So Vx is written as 5 minus 10 I1 dash minus 2 I1 dash. Upon solving, we will get the value for I1 dash as 0.54 amperes, upward direction. Then the second step, consider the 2 ampere source alone. While considering 2 ampere source alone, replace the voltage source with a short circuit. So the diagram will be like this. Now our aim is to find out this current I1 double dash. In order to find out this current, we are using mesh method. Now from, two mesh currents I1 double dash and I2 are marked like this. Now from this equation we can write Vx will be equal to minus 10 I1 because Vx is the potential across these 2 terminals. That is potential across the 10 ohm source. Potential across 10 ohm source is 10 into I1 double dash. And current flows in this direction. So it is a negative 10 I1 double dash. Now let's write the second equation from the diagram itself. From this circuit diagram, we can write I2 minus I1 double dash is equal to 2. I1 double dash flowing downward, I2 flowing upwards, net current is 2 ampere upwards. So we can write I2 minus I1 double dash is equal to 2. So we got two equations. Next step is to apply KVL to this loop. While applying KVL to this loop, equation will be like this: minus 10 I1 double dash minus 4Vx minus 2I2 is equal to 0. Substitute the value for Vx from this equation, from equation number 1. Then rearranging the terms of I1 and I2, we will get the equation like this. Now solve equation number 2 and 3 and find out the values for I1 and I2. I1 double dash is 0.14 ampere upwards. Now applying superposition theorem, I1 is equal to I1 dash plus I1 double dash. I1 dash is 0.54 ampere upwards. I1 double dash is 0.14 ampere upwards. So net current by superposition theorem is equal to 0.68 ampere in upward direction. Then we are moving to the next problem. Dear students, all of you do this problem as homework.